everyone. I'm Hongkai from Warwick Computer Science, and I'm also affiliated with Samsung AI Research at Cambridge. So my background is more in machine learning systems, and it's good to see you all. I'm relatively new to this area. So happy to discuss most of the recent work on urban analytics, particularly in mobility systems, in collaboration with colleagues from Exeter. So we are particularly interested in one type of a mobility system, the shared electric mobility system. You see all of those systems appear in big cities like London, the e-golfs, the Zipcar in London, and Singapore and Shanghai. It is a relatively new modality of urban mobility, and people are saying that it's more affordable. Of course, it's cut unnecessary emissions. And we worked with one of the biggest players in the sectors for a year in Shanghai, and we collected lots of data, how they operate, and lots of other data like points of interest, the geospatial stuff. And we want to understand how they work and how to make those systems work better. So the first challenge we're facing is really the dynamics. Those systems, because they're so new and they're not sitting ducks, so they are actually expand every day. So you see that new stations deployed every day, the stations closed every week. So this makes things very tricky. The first problem we try to tackle is how we understand the demand of the users. How we actually predict when the users are going to use those systems. So instead of using a traditional approach, we use a graph ML approach to capture both the spatial correlations and the temporal correlations. So we run a time-varying graph, multiple time-varying graphs on top of the system, and use that to conduct multi-score prediction to understand what would be the next order and what would be the average next order in the next week or next month. And the next natural question would be, okay, we understand how the user uses the system, then how about, can we make the system more efficient? Can we make the system satisfy more user orders while getting more money? So that's basically related to how we optimize the infrastructure with the system and in the presence of strong spatial and temporal correlations. So what we did is we tried a deep neural search approach. Instead of the traditional approach, we run a neural search on a simulated environment, and we use reinforcement learning to actually sample possible deployment plans, how we find the optimal strategy or near-optimal strategy in space and time. Then the final question that we consider is about the fleet. Because the system is actually driven by the users, so naturally as you go from day 1 to day 31, even just with 1 month, the entire fleet becomes very imbalanced. So instead of hiring a dedicated team of staff to actually drive the system around, drive the vehicles around, what we did is we actually developed rebalancing strategies by even incentivizing the users, giving user discount in exchange for their cooperation to rebalance the vehicle for us. So again, we use reinforcement learning in that and try to directly model the constraints in those cases. And I would also like to raise discussions in the work in progress projects. So one of them that we're interested in is how we actually make the data privacy aware. So as you all know that when we actually release the data to the public, then there's privacy concerns. So instead of doing that, what we're thinking is, can we actually build generative models that can produce those synthetic data which does have the similar statistical properties, but with theoretical privacy guarantees. We've done some trial studies, and we have preliminary results on the submission. And the next thing we want to do is, can we automate the entire machine learning pipeline for spatial analysis? So for now, what we did is we manually designed a network, manually designed different approaches for urban analytics. Then the question is, can we automate the entire process and just one click to generate the models that's suitable for your need? Thank you so much.